Hello, everyone. Welcome to this special little question and answer event we have today. I'm here with Sai and Naren from Floyd Hub, and over the last week or so, we've been collecting questions from you, and they are here to answer those questions. So to start with, I'm going to let them introduce themselves. So, Sai?
Thanks, Matt. Hey, I'm Sai. I'm one of the co-founders at Floyd Hub. We try to make the engineering aspects of deep learning easier. I started working in the deep learning space a while ago, back in 2008, 2009, when the term deep learning itself wasn't that popular. It was just called massive neural networks. GPUs weren't really used, and it was considered a really difficult task to identify a mug that was placed on a fairly clean table. And we've come a long way since then. More recently, I led the deep learning research efforts at Bing and Microsoft, where we did a lot of NLP, deep learning for NLP. So I'm really excited to be here. I think we have a good set of questions and happy to answer them.
Cool. My name is Naren. I'm Sai's co-founder at Floyd Hub. Before Floyd, I was working at a company called Location Labs. We got acquired by Avast last year. I was a software engineer there. I started out 5 years ago, and most recently I was the director of engineering there. Before Location Labs, Sai and I both went to Stanford. That's where we actually met. Yeah, I have a lot of engineering background. I've been building systems that scales and serves millions of users, and really excited to be building Floyd Hub. Yeah.
All right, thanks. So let's get started with some questions.
Sounds good.
All right. So the first one is from Ludwig Trammer, who says, "Hi, big fan of Floyd. My question is it realistic for a guy or gal with a programming background to get a career in deep learning without going through academia?"
I think so, absolutely. It depends what kind of career he's talking about. If it's a career in academia itself, then I think it's kind of a prerequisite. That's how the system works, to have a PhD at the least. But if it's in the industry, I think what we look for when we're hiring, or a lot of people in the industry look for, is just the ability to execute. If you have the ability to bring stuff to work and get things to work, I think it's becoming less and less important what's on your resume than compared to what you can actually do. And this applies to deep learning, obviously.
Yeah, and that's what we're trying to do here at Udacity.
Absolutely,
also.
yeah.
So then he also asks, is it better to focus on learning about deep neural networks and trying to keep up with what's happening in the field, or get back to basics and learn about data science in general first?
The distinction between all these fields, data science, machine learning, and deep learning, is kind of becoming fuddled by the day. So what's worked best for me is to not focus on the distinction, rather take an end application, work towards that, and do whatever needs to be done, right? There's obviously going to be a certain amount of data science that needs to be done to even get to the machine learning aspect and then deep learning. So yeah, I would say focus on building something, like I said, execute something that's of value, and whatever it takes to get that done.
Yeah, makes sense. Okay, so this next question is from Thomas Johnson. So he says, Andrew Ng has said that the best way to become proficient in deep learning is to take published papers and try to replicate them. In my experience, this is a very good method for learning this stuff too. So can either of you recommend some papers to start with? He says he's particularly interested in 1D time series, so like natural language processing, speech recognition, that kind of stuff.
Yeah, I don't think it's less of my place to recommend a paper, and it obviously depends a lot upon their interests. I would say what's more important is implementing some paper, getting something done. That's way better than not doing anything, right? So the right way to probably think about this is to choose a paper of your choice and choose something simple, right? There's a lot of complicated stuff out there. You don't want to get demotivated on your first project. Choose something simple, implement it, and preferably choose something that's the amazing thing about the deep learning community is that a lot of it is open source. There's a lot of stuff on GitHub. Choose a paper which has a GitHub implementation. Use that as a reference, implement your own version of this, and now you have something to compare yourself against. The choices that the folks who have written the paper have made and how they compare to your choice. This is a great learning opportunity. So I would say start something simple, like CAD, RNN, if you're interested in NLP. Fairly simple stuff, but do something. It's better than waiting for the best paper to implement.
Sure. So then he also asks, so what do you recommend if like he has a question about details of a paper? So like where can he go to get help on like building like a WaveNet or something?
I think being part of Udacity, that's one of the amazing things about this. This is super vibrant Slack channel here. So I would say that's the first place you should go. You have amazing instructors, people you can people you can help who can help you with. You have the amazing community. Do that, right? And let's say after this, I think the thing that's important is you should be open to asking. There's a lot of forums. There's a machine learning subreddit forum which is extremely open to answering questions about any sort of machine learning, deep learning. Use that. There is Hacker News. There's Quora. There's Stack Overflow. And apart from all this, like since it's the same person asking the questions, if let's say you're implementing a paper that has a reference implementation, feel free to use GitHub's issues to ask questions. Oftentimes the authors of these papers hang around there. They're really willing to help, but you should be willing to ask.
Cool. Yeah, I've noticed that a lot too. Like a lot of these implementations are on GitHub, so you can get the code and you can like talk to the authors. It's really useful. Hey, so then this is more about like FloydHub specifically. So why did you choose K80 GPUs as the basis of your GPU computing? So why not like Titan X or 1080s? Yeah, so why did you choose this as compared to other?
I will defer this to Naren. He's the engineering expert.
So we definitely thought about all kinds of GPUs out there in the market, and one of the biggest constraints for us was we want some product to be out there soon, so we want to get validation for our idea. On the other hand, we want to also make it really cost efficient for the people to use. In this case, students. One of the things is NVIDIA has these restrictions on what kind of GPUs you can use on virtual devices. So, for instance, the consumer-grade GPUs that's the person asked about, those things you cannot use in a virtual device. Like you cannot put it in a virtual machine and use it. So, with that constraint, we wanted to that's why you see all these cloud providers. They all provide K80s because that's what NVIDIA wants everybody to use. But having said that, we're already thinking about what the next step is. We want to bring down the cost for ourselves and give it to the end user. So there are things in works, and I hope we can release something pretty soon.
Yeah, I'm looking forward to that.
Yeah.
Cool. Okay, so then this is from Adam Gutierrez. So if an applicant had a Udacity Nanodegree, what other requirements would you look for to hire?
Yes, the Udacity Nanodegree is great, and it's a great platform for you to start proving yourself. You learn a lot of fundamentals, and one of the things that's great here is I see a lot of this stuff being project-driven, so that gives you the ability to work on real stuff, right? So when we talk about hiring, we see we care less about what's on your resume compared to what you've done, what you're capable of doing. So if you can basically show that, not just to us, to any employer, if you can show that, that would be awesome. Yeah, feel free to take a project, implement it, contribute to an open source project, write a blog. There's a scarcity in the amount of information about deep learning out there. So write a blog. You will become super popular, and people are going to come to you.
Yeah, I've definitely noticed that about blogs. Is I'm teaching this stuff and trying to find good resources, and there's only one or two blog posts about any particular topic, right? And so I'm just trying to kind of prove yourself to employers. So this is from Ji Lu. They're asking if I would like to use the same features trained by a neural network for two tasks, may I have two objective functions for a single neural network? Or how could I combine them?
I think so, yes. This is the concept behind, one of the concepts behind transfer learning, where you can take, let's say a VGGNet, for instance, which was primarily built for image classification, and then use this for different purposes related to, with similar tasks, for instance, face recognition, for instance. There's a lot of ways to go about that. You can do what you mentioned. You can take a layer, take a network, freeze a layer, and then change just the last few layers. All these are possible. So I think it's definitely a valid approach, and the best way to validate is to try it out.
Yeah. Yeah, I've seen VGGNet used a lot in multiple projects. So you can just find it on GitHub, and somebody just uses VGGNet as kind of the basis and then builds off that. So I think it's a very good approach. If you could pick one industry to transform or revolutionize with current deep learning techniques, which one would you pick?
I can give my stab on, and then you can. I think it's an important philosophical question for all of us, for humanity. So I would say medicine, right? Cancer cell detection, drug discovery, genetic therapy, and increasing lifespan of humans. I think as humans, we have an intrinsic motivation to keep our genes in existence on this planet. So I think that's something we would probably see a lot of incorporation of technology. One of the problems that's been in the past is there has been a gap between technology and a lot of these other industries, and that gap is becoming less and less significant. I definitely see a lot of AI and deep learning being applied to this. It's going to be pretty awesome.
For me, I agree. I think medicine is a huge area that's going to get disrupted. The other area I think it's already happening is transportation.
Yeah.
I feel like I think we spent like 1.5 hours on the road because of an accident on 880. It seems like we should be like doing work while we are in the car, right? Like self-driving cars are going to happen. It's not just like cars, like trucks. Truck drivers spend a lot of time on the road, when they should be at home. Spend their evenings with their kids, and a lot of companies are tackling that problem. I can see that in the next 10-15 years, that industry is going to get changed a lot. It's going to be more efficient. Save a lot of lives in the process. So that's I'm really excited about that.
Yeah, I thought the same thing this morning because I was driving through the same traffic accident. I was like, man, it'd be really nice if I could just be doing work while I'm in my car. That'd be great.
I actually did. I was on a conference video call while he was driving, and the first thing the person asked me on the other side asked me was, "I hope either your car is not moving or you're in a self-driving car." I'm like, no, my co-founder is driving, and I'm just in the passenger seat.
Nice. It's awesome. That's what I'm really looking forward to. Like the automobile industry, right? Because I think it was Ford said they're going to have an automated car in like 2021 or something, and that's only like 4 years from now.
Yeah.
And I bet like all the other car companies are trying to catch up too. Yeah. So I'm really excited about that.
Awesome.
Yeah. Okay. So then, kind of on the other side of this, what's your biggest fear considering the current state of the art deep learning? Like, what if it ends up in the wrong hands?
I think the fear is a little misplaced. Definitely there's a possibility of not just deep learning, any kind of technology being used in the wrong way. I think the fear in people's mind is, what if machines start thinking for themselves and we have the next Terminator come up and have cost rampage. So I think we're really far ahead from that happening. Probably not in our lifetimes. So there's a difference between intelligence and sentience, and intelligence is what we're building towards right now. The ability for machines to think and feel is so far ahead. And to quote Andrew Ng on this, he said, thinking about things like this is like thinking about how to control overpopulation in Mars. We're not even there yet, so we'll worry about it when it comes. That said, we all have, as practitioners and researchers in this field, we have a responsibility to make our work socially good and socially not evil. And efforts like OpenAI are attacking this. They're tackling this. So they're trying to make the whole field of AI more open, not just in the hand of big corporations. I think they're doing some amazing work. And as researchers, I would urge everyone to be socially responsible in what they do.
Yeah, excellent. So this is a question from Deepak Verma. So it's kind of along the same lines. So then, what other physical AI interventions will we be seeing in our cities, like other than like self-driving cars? So like, what other kind of improvements could we make to our cities using artificial intelligence and deep learning?
I think there's going to be a lot. There is already a lot, right? So one other way to think about this is, instead of thinking of end applications, think of more basic stuff. For instance, there's going to be improvements in computer vision. There are improvements in computer vision. And this is going to lead to things like self-driving cars, drones, surveillance cameras, and a lot of other things, whether we like it or not. There's a lot of other physical manifestations. Like, for instance, your phone. They're going to get more and more intelligent. When you speak into your phone, the voice recognition uses AI. The ability to understand this and transform that to an action, that uses AI. And this is only going to keep improving. That said, it's kind of difficult to predict where the market is going to head. The Internet of Things revolution should have happened a few years ago, and people were super excited about it. I mean, I don't know if maybe it's still happening, but it's not super popular yet. So it might take time for things to manifest, but it is going to manifest in ways that we expect and ways in which we don't expect as well.
Yeah. So along those lines, I think Alexa is like kind of getting like normal people into this AI stuff right
Yes.
now, right? So it's like really taking off. So it's good to see that like people are welcoming AI into their homes.
Yeah,
Right.
no, absolutely, yes. And the barrier between AI machines and humans is going to be less and less. So you're going to interact with AI without actually knowing that you're
Yeah.
doing it, and it's going to be awesome. It's pretty scary when you think about it sometimes, but yeah.
Yeah. So this question is from Francisco Sosa. So how is Floyd Hub helping reproducibility in deep learning?
So one of the things that when we started building Floyd Hub was, Sai being a deep learning researcher, one of the things that came up is, you run a lot of experiments because you're basically trying a whole bunch of parameters. You have to try a lot of different things to figure out what actually works. That means you're running experiments over a period of weeks or sometimes months. So when you go back to something a month ago, you actually want to be able to say, how did I get this end model? Like what was the parameters I used? What was the environment? And it's super valuable for someone to be able to rerun it and get the same results, because there's like other people building on top of it. So you just want to make sure that the reproducibility is there. So the way we achieve that is by snapshotting the entire experiment. So in GitHub or in Git, you just snapshot the code, so you know at every version what was your code. But when you run an experiment, it's beyond just the code. We snapshot the environment that you ran, what are the parameters that you used, what TensorFlow version, and we have all those references, and what are the outputs you're getting, the models and things like that. So when you go back and kick off the experiment again, we can guarantee you that all of this is going to rerun in exactly the same environment, so you're going to get the same results. So yeah. So that's how we get reproducibility. Yeah.
Yeah, one feature I really like about Floyd Hub is being able to like upload data like on there, and then like you can like share it with other people and have it yourself.
Yeah.
So I think it's a really nice feature.
Yeah, we feel like especially in deep learning, the data sets are going to be like huge. So in a university setting or like in a Udacity, like there are thousands of students. We don't want everybody to like wait for the upload to happen. So instead, like we could host once. Everyone can just like access it during their experiments.
Yeah. So like in our second project, we're using the CFAR10 data set,
Right.
which you guys have preloaded.
Yeah.
So it's really easy for our students to just like start up the project notebook and then connect to that data set and just have it there without having to download it.
Yeah.
So, great bonus.
Yeah, and hopefully in the future, if you get to bigger data sets, this is going to be even more useful.
Definitely. Okay, so then continuing, so Francisco Sosa also asked, are you adding support for TensorFlow serving? So, and how will that help deploy deep learning models?
Yeah, so we definitely started looking at TensorFlow serving. I mean, TensorFlow serving is the way you when you have a built model, you train a model, and then you want to be able to expose it as an API, so you can like query it and get the results. TensorFlow serving, getting it running out of the box is actually incredibly difficult. So one of the approaches that we took was we actually want to make it more generic, so you can actually serve any kind of models, not just TensorFlow or any platform. So let's say you use PyTorch, then you have a model, like how do you serve that? So the approach that we are going towards is like building a more generic serving framework where you have a simple REST API that you can send any kind of data, and you invoke the evaluation function that you have and handle the result back. Obviously, this is our V1 version of serving, but we are definitely going to invest in more into this and make it a more seamless serving experience. This is super useful, especially when you have trained a model and it works well. You're super excited. You just want to share it with your friends. You can just like send this API, and they can just play around with it.
Yeah. Nice. So along with PyTorch, I saw that you guys like recently like added a bunch of different frameworks to Floyd Hub. Like, what all do you have now?
We have pretty much all the top frameworks. We have TensorFlow, Theano, Torch, PyTorch, Caffe, Keras, Chainer, MXNet.
Yeah.
Basically, we have everything. We have more than people are actually using right now.
But that's, I mean, it's good to have options.
Yeah,
So,
absolutely. Yeah. And yeah, we've been doing this based on request. It's fairly simple for us to. We're agnostic to the frameworks that we run, so we can pretty much run anything and pretty in the future, we might actually make it open for so people can add their own frameworks as well. There's going to be a lot of new frameworks coming up. That's my prediction. So we'll be able to support it all.
Nice. It's good to hear. So this is from RJ. You described Floyd Hub as a platform as a service company, so Heroku for deep learning. But while Heroku is pure PaaS, with, I'm not sure what all these acronyms mean, with IaaS provided by AWS, Azure, Google, user's choice, it appears that Floyd Hub is like a combination of these two. So do you, yeah, so is it true that it's a combination?
Yeah, I agree. I think what this person means is that there is the concept of platform as a service and infrastructure as a service. I think that's what IaaS is. So yes, we are actually a combination of both. We picked Heroku for deep learning as our tagline because it's really easy for people to communicate what we do, but it's not entirely what we do. There's other stuff that we do. One of them is we manage the infrastructure. When you want to scale your experiments and you want to have, I just want a bunch of machines, I want to run all these experiments in parallel, we take care of spinning up the right kind of machines, making sure they have the right platform, framework installed, CUDA drivers and things like that. So all of that happens behind the scenes. So for the end user, it's a seamless experience. You just say, I want to run my code in a GPU environment with TensorFlow 1.0, and then we make it happen. But it is true. We are both platform and infrastructure as a service. Yeah.
Nice. So then, okay, so how can you provide competitive GPU compute prices while competing with 800-pound gorillas like AWS and Google?
Yeah, it's we get this question a lot. So one of the things that we've started building up right from the beginning is a lot of technology around how do we share these resources really well. With the given set of instances we have, we want to bin pack them close enough that each user just pays for what they use, but at the same time we also efficiently schedule a lot of jobs on the same instance. And we use we've been constantly improving this. The other ways we are we also reduce costs by getting reserved instances and using spot instances. Wherever we can cut down the cost, we do all of that in the background. Again, we don't want the end user to worry about oh, this is expensive, I should be turning this off. Instead, they should just be worrying about, I'm just going to run my experiment and it's done. I just pay for what I ran.
Yeah, I really like the model. In my use of Floyd Hub, it's really nice. I just load it up, and then when I'm done, shut it down, and I just don't have to worry about any of that stuff. Yeah. So it's nice. Suman Chatterjee is asking, so AirPoly Vision is an iOS app which uses deep learning for object recognition. So it uses a convolutional network directly on the phone and works without an internet connection. So can you give an idea how this app can be developed and how it works?
I think phones are becoming more and more popular. They have pretty good GPUs in them, so I wouldn't be surprised if that this is happening. That said, there's a couple of things that you can do. One is there are deep learning frameworks specific to optimized to run on iOS and mobile devices. Deep Learning Kit, I think, is one of those. The other approaches that a lot of different services take is to have a simpler version of your model run on your phone. Don't have too many layers, reduce the number of multiplications that need to happen, and that tends to work well. Again, I don't know exactly what these guys do, but for instance, if you use Google Now or Siri, when it does the voice recognition, it still works if you're not connected to the internet, but the quality is significantly worse.
Yeah.
Because it's using the local model, much simpler version of it. But I think we're going to see improvements, and we could possibly in the near future have full-fledged models running on mobile devices.
Yeah, because I know, so TensorFlow was built to run on phones and whatever, right? So anywhere that can be run, TensorFlow can do it, right? So I imagine there's a lot of programs like these, apps like these, that have a TensorFlow model underneath, right?
Yeah, sure.
This is kind of a long question. So in mathematics, they say that David Hilbert was the last mathematician who understood all the mathematics of his time. Now it's even impossible to understand all the mathematics of a single branch. So also at some point, there were many amateur mathematicians like Fermat who did great things. But okay, so for deep learning and AI in general, do you think it's better to try to be a generalist or to specialize in a single topic? Yeah, so there's multiple questions here. So
Okay.
Yeah.
Yeah, so let's do the first one. I read somewhere that there's more humans alive today than has ever existed in the history of mankind. It's kind of fascinating if you think about it, right? And that's kind of how things grow. At some point, it's going to be impossible to even know what you can learn, let alone learning it. And technology and all this information is basically growing exponentially. That I think we should stop holding on to the notion that we need to know the whole field to get started, right? So in that sense, I think that's perfectly fine. That's how the whole evolution of technology and pretty much all kinds of information happens. In terms of being a generalist versus a specialist, I think it's up to a person's personal preference. What's worked good for me in the past is to start off as a generalist, because when I start off with a new area, I'm not really sure what my liking is going to be for the specifics. Start off as a generalist, try out a few things, and if you really like an area, become a specialist in that. So that would be what I would do if I was in this, if I had this thought.
Yeah. Yeah, it's similar to my grad school experience, where I was kind of learning about neuroscience in general, and then I found this one thing that I was really interested in. So then I kind of specialized in that part.
Yeah.
Yeah. So it's probably if I was going to be a deep learning researcher, I'd probably go along the same routes
Yes.
as that.
Yes. And I think this advice applies in general.
Yeah.
To a lot of different things also.
Yeah. So what do you recommend if one aspires to contribute new techniques to the state of the art and not just implement current algorithms?
I think a good place to start is to implement current algorithms. Like one of the questions before was, how do we take papers and implement them, right? So yeah, that's a great way to start doing this. Take an existing paper that has a reference implementation, implement it, compare yours with the existing version and see how your choices differ from the choices that others have taken. And maybe your choices are much better than them. There you go. You're advancing the state of art at this point, right? I think the way to think about it is not about to start a day saying, hey, I'm going to come up with something that advances the state of art right now, but you do something and that accidentally or just by means of the effort that you put in does advance the state of art. That's a much easier approach than doing a top-down.
Yeah. Yeah, going back to my research, I mean, basically the way all PhD dissertations work is that you're building off of other people's work, right? And so it's you do this literature review, you see what they all did, and then you find one thing that you can improve, right?
Yes.
So it seems like that'd also be a really good way to apply it to this, right? Because I mean, deep learning today is still very research oriented,
yes.
Right? So if you just find something and then tweak it, make it better. And then publish on arXiv or something.
Absolutely, yeah. and also, the state of the art in different areas is different, right? For instance, CNNs started being used in images, and then audio first, then images, and then they started being used in text, for instance. So using CNNs to do text sentiment classification was considered state of art at some point, and then RNNs came along and started doing this. So yeah, so exactly what you said, do a literature survey, see if there's techniques that can be transferred across domains, and totally agree with you on this.
Yeah. So we had a question similar to this before. So is a PhD necessary?
I don't have a PhD. So I have a master's in this space that was focused more on AI and robotics with some application in deep. Like I said, back then, deep learning wasn't really a popular term. But yes, I don't think it's really necessary unless you're going into academia at this point.
Yeah, makes a lot of sense. So this is a question for both of you. So can you describe your journey to launching your business? It's an interesting concept. So this is from a student on Slack. They're called Nagu. Maybe it's his first name. So you tried to bootstrap a similar idea with data modeling as a service, but failed. So he's just interested in how you guys managed to launch Floyd Hub.
So the way this happened was sort of happenstance. So I was working at Microsoft, did a lot of deep learning there, and personally, me and my team there have had a lot of difficulty just bridging the gap between data science and then the engineering aspects to get the data science in reality. It's a lot of infrastructure, a lot of engineering work that needs to be done. There was a lack of tooling. So a while ago, this was earlier last year, I created a GitHub repository called DL Docker. That's basically a bunch of instructions to set up all the popular deep learning frameworks. And I created it, didn't think twice about it, went to sleep, and then turned out someone posted that on GitHub on Hacker News, and then it became really popular. There was a lot of discussion around this, and that's kind of the first time I actually gave serious thought into building this into a product. And a few days later, I called Naren. Naren was my classmate at Stanford, one of the best engineers I know. So I called him and I'm like, dude, this sounds good. Do you want to take a shot at this? And when we initially started out, we were not exactly clear on what we were solving. So it was a lot of trial and error. And I think one thing that everyone wanting to get into the entrepreneurial or startup space should have is persistence. Just try out a lot of stuff, get a lot of feedback. We've had to iterate on our product quite a bit. I mean, we're definitely nowhere close to being perfect. We're still iterating on our product actively. It's quite different from what we had like a month or two ago, 2 months ago. So do not be discouraged if your idea doesn't take off. This is probably my 15th startup idea.
Yeah.
First actual startup, but I've tried a lot in the past that have never taken off. I would spend like 3 months of intense effort doing it. Just turns out either I didn't persist or turns out I was building something that no one needed. So we were excited to be at the space. We're excited to be working with Udacity, and we've been getting a lot of feedback from the students, and which is really amazing. And I don't think we've got so much focused feedback from one group in a single place in such a short time. And thank you all for all the feedback. And we strive to make things better every day. So we want to streamline your process. We feel deep learning should be easier than it should. As part of being, let's say, the Deep Learning Foundations Nano Degree program, you should focus on the deep learning and not have to worry about setting up AWS.
Yeah.
And we hope we can bridge this gap and make things easier.
Yeah, I've been really impressed seeing like how quickly you are to respond to students. It's like in Slack, and they say, "Oh, hey, Sai, like what's going on with this part?" And then you guys just like immediately jump in and help them out.
Yeah, I mean, I think like in terms of the people who's trying our product, I think the students are like really nice about it, right? Like they understand it's a work in progress, and they saw the first version like 3 weeks ago. And they know it's not perfect, but they still give us feedback. Hey, these are the things that will help us improve. And then we fix it and push it back, and they're like they acknowledge it. They're like, oh, this is awesome. You guys pushed this feature, and I'm like, we're happy about it. So it's really good to get that feedback from them. It kind of energizes us. Like, oh, that's awesome. People are like seeing what we're doing. So it's really awesome.
And we take feedback seriously from users. So we had an investor who's also very technical and uses our product really actively. So he was telling us, you seem to respond way better to me when I ping you as a user of your product than as an investor. Like, that's true. Yeah. We're grateful for all the feedback and hope we can continue improving.
Yeah. Okay, I think that's all the time we have for questions today. I'd just like to thank you for coming and doing this for us and like for the students. And I'm really excited to like get our students to start using Floyd more, because it seems like from my experience and from our student experience, it just makes deep learning so much easier than like what we're able to use now.
Great, thanks for having us. It's been an amazing journey working with you guys for the last 2 or 3 weeks, and we hope to continue this in the future. Thanks so much for having us. It's been a pleasure.
Thanks, Matt. Thanks for having us. Yeah.
Thanks. Okay, cheers.